Welcome back to some more geometry. Today we're continuing our talk about proving triangles congruent. We're using the ASA and the AAS method. Let's talk about that. Move this out of the way. All right, so we'll start with angle, side, angle. Now, like we did with side, angle, side, the main part is we got to remember the included part. So here we have two angles followed by an included side. So the included side means it's the side that's in between the two angles. Okay. Before we do this problem, to kind of support it, we're going to talk about parallel lines. So back in many chapters ago, first semester, we talked about how there's certain groups of angles. So for example, these two angles in a parallel line. Now, you know these lines are parallel because they put little arrows right here. Those two angles are congruent because they're what we call corresponding angles. Okay, we know that this angle right here, no, not that one. Let's do the other one. That one can work too, but we're gonna do this one here. This angle right here and this one over here, they're congruent to each other because they're alternate interior angles. And then we also know that these angles out here, this one and this one and this one and this one, it could be the other set as well. They're alternate exterior angles. All three sets of these angles are congruent. They're all equal to each other. All right, so now that we're all on the same point, let's look at this problem right here. So in this problem, we have two sets of parallel lines, AB to CD and BC to AD or DA. So that kind of makes this BD right here the transversal, the one that kind of cuts those, similar to this line right here. This is the transversal here. So we look at this problem. All right, we know we have 60, 60, and then we got these two angles. Well, if we know these lines are parallel and we have a transversal, we can say, well, if this angle right here is 61, then this angle over here is also 61 by alternate interior angles. And if this angle right here is 59, then this angle over here is also 59 by the same reasoning, alternate interior angles. Well, we have angle to angle, angle to angle here that matches up. So when we talk about the included side, the side that has to be congruent is the one in the middle, the reflexive angle. The BD right here is congruent to DB, the other way around. Because of that reason, they're backwards to each other, because if we look at the BD on this side, it goes from 61 to 59. So to match it up, we have to talk about it as DB on the other side. So these triangles are congruent by angle, side, angle. So we got an angle followed by a side followed by another angle to its counterpart over here, angle, side, angle. All right, so let's look at this proof right here to kind of support this. So we know that our given information is ZX bisects angle WZY, and ZX, that same ZX, also bisects angle YXW. All that is given information. All right. So let's kind of go from there. ZX bisects this angle WZY. So this whole angle right here got bisected. So that implies that if this angle got bisected, then we got these two smaller angles that are congruent to each other. So we can then say angle WZX that's congruent to angle YZX by what we call the definition of angle bisectors. Anytime something's cut in half, or the exact words bisected, whether it's segments or angles, then it's by definition of that segment bisector or angle bisector in this case is why it creates two congruent parts. That's the definition of to bisect, two equal parts. That same ZX also bisects the angle up here, YXW. So then we can imply that angle WXZ this time is congruent to angle YXZ by the same reason, definition of angle bisector. So we have our angle and we have another angle. So we have angle to angle, angle to angle. So we got those congruent. So now we need our missing side. In this case, the included side, the one right in the middle. Now in this case, it'll be ZX to ZX because the angles match up nicely. the z on this side versus the z on the bottom, they match up. The x on top, x on the bottom, they match up. So that's our reflexive property still, reflexive property. So here's our side. So all three lead to our final statement. Because we have all three parts, we could say that the two triangles, triangle WXZ, is congruent to triangle YXZ by angle, side, angle. That's how that works. Now the next one right here, very similar, has two angles, but this time we're talking about the non-included side. So what does that mean? So let's say we are talking about angle A and angle B, a D right there. They're congruent. And then B and E down here, they're congruent to each other. All right, so they're congruent. True. So when talking about non-included, the real question is not which sides have to be congruent, it's which side can't be congruent. AB cannot be used to say it's congruent to DE, because if we do say that, then we're saying angle, side, angle. But to use angle, angle, side, we have to say BC to EF or DF to AC. We can use either one. We can say angle, angle, side, or angle, angle, side, but we cannot use the middle one. If we do, which we're not saying we are not allowed to, it's just if you do use this, the side that's included between the angles, then we're talking about angle, side, angle. So this is all about the order we do it, but other than that, they're basically the same thing, two angles in one side. It's just what side are we using, the ones outside the angles or the ones in between the angles. That's how you tell the difference between these two. All right, let's do a proof to kind of support this information right here. So we got all this given information that they give us. RQ is congruent to ST, and then that same RQ is parallel to ST. That's also given information. All right, so that's what these little marks right here mean, congruent, congruent, and then the arrows right here means the parallel. So that means this line is parallel to this one. So we treat RT and SQ like transversals. So they're telling us that angle RQS, this angle right here, is congruent to TSQ, this angle up here. What is their relation to each other? They are congruent, like we said, but in what manner? Well, if you guys remember, we talked about at the beginning of this section, they're congruent by being alternate interior angles. They are alternate interior angles, means they're congruent to each other. All right, now we got vertical angles. And now somebody asked me a question, I don't get vertical angles. And I can see how that can be. Now, vertical angles are two angles that are across from each other. It happens when you form intersecting lines. It forms two sets of vertical angles, these two, and of course, these two over here. So on here, there's only one point where the vertical angles can exist. It's right here at U. But we are talking about angles that are in the triangle. So it's not the top and the bottom, it's the two inside the triangle. These are vertical to each other. Those are the only ones that are vertical to each other. So when we write it out, let's say, all right, which in what method? So if we're going to start with Q, we say, hey, Q, U, remember the middle letter is where the angle is actually at. The other two letters tells us where to start and where to end. So Q, U, R is congruent to angle. What's Q's counterpart on the other triangle? S. S, U, T. So Q, U, R is congruent to SUT by vertical angles. So now we have an angle followed by a side, an angle followed by a side. So now we can see our triangles are congruent. Triangle RUQ is congruent to triangle TUS by the angle side. There. And that's it, y'all. Hopefully that helps. Have a great day. Bye.